Hey, how's it going, you guys? So today we're going to go over chapter 91, Introduction to Hybrid Vehicles. So it's just going to be the basic rundown of, how hybrid vehicles started, and also just how the evolution of the technology that we actually use for hybrid vehicles nowadays, and just the fundamentals of what is an actual hybrid vehicle. So I'm going to discuss the evolution of electric and hybrid vehicles. I'm going to describe how owning a hybrid electric vehicle is different from a conventional vehicle, and then explain the classifications of hybrid electric vehicles. And also, I'm going to explain the operation of belt alternator starters, or BAS systems, and discuss the common features of most hybrids and the levels of hybrid vehicles. So there's not just one type of hybrid vehicles, there's actually different stages and different amenities that you get with each different type. So let's first talk about the definition of a hybrid vehicle. So what is a hybrid vehicle? A hybrid vehicle is one that uses two different methods to propel the vehicle. Most hybrid vehicles use a high voltage battery pack and combination of electric motor and generator to help or assist a gasoline engine. In some designs, it is capable of propelling the vehicle alone without having to start the internal combustion engine. So most newer vehicles nowadays are actually using the electric system a lot more, being able to propel the vehicle without actually having to have the internal combustion engine on. So the engine can actually shut off while still actually driving the vehicle using electric motors and obviously the battery. Early electric vehicles. The controller was operated by the driver and allowed different voltages to be applied to the electric motor, depending on the needs of the driver. So different scenarios where you need to accelerate harder, or you're just going to be cruising, they actually monitor and adjust the voltage that's going to the electric motors to give you that correct amount of power that is actually being needed by the driver. Early electric vehicles did not have a long range and needed to have the batteries charged regularly, which meant the electric vehicle could only be used for short distances. So the first electric vehicles around were very short trips. So, be someone who lived in a small city where they're just going to the supermarket, or they're just going to go to yoga or whatever. Because obviously the first electric cars are owned by and driven by, tree huggers. And the batteries didn't last that long. In some cars you only get range of like 80 miles until you had to charge. And the charging wasn't just a 20-minute charge, like our fast charge on our phone anymore. It was actually through, about 12 to 14 hours it would take to actually charge these cars to go only about 80 miles. So they would go to do their quick trips around the town, then they would come home and they plug it in and they'd be ready for the next day. Newer electric vehicles. In the late 90s, several vehicle manufacturers produced electric vehicles using electronic controllers to meet the demand for zero-emissions vehicles. By 2010, there were several electric vehicles for sale, although often in limited parts of the country and in limited numbers. One of the last remaining General Motors electric vehicle, one on display at the Peterson Museum in Los Angeles, California. So this is actually a GM vehicle. I wouldn't consider it a Chevy or a Dodge because it actually doesn't have, not Dodge, a Chevy or I believe Buick is a GM product. It was actually just a GM vehicle. So it's not particularly a Chevy or a GMC. There we go, this is the other one I was thinking about. And just going back to this picture, you can see when they started coming out with electric vehicles, they started to make them more streamlined, very egg-shaped, just to allow for lower wind resistance and less drag on the vehicle, which means the cars can actually drive longer. If you try to make a electric vehicle in the shape of a giant brick, it's not going to go as far as, say, this one actually did as far as the range, because now you're fighting drag, you're fighting wind resistance, so now you're going to have to step on the throttle a lot more to be able to maintain speed, which means your battery is going to deplete a lot quicker. General Motors EV1 showed without body many of the features of this vehicle, such as regenerative braking, currently used on hybrid vehicles were first put into production on this vehicle. I'm going to kind of touch bases on regenerative braking, what it does. We're actually going to go more into it in the next couple lectures. This week we have 3, so we have chapter 91, 92, and 93, and it's going to be mostly based on the hybrid systems themselves. Driving and owning a hybrid electric vehicle. Driving a hybrid. Some unique characteristics that the driver may or may not notice include the engine stops when the vehicle slows down and stops. The brake pedal may feel different, especially at slow speeds of about 5 to 15 miles per hour when slowing to a stop. Some hybrid electric vehicles are able to propel the vehicle using the electric motor alone. So a lot of the times, Prius vehicles, they do this when you're actually coming to a stop. It'll actually shut off the motor because the engine doesn't need to be sit there idling. It uses the actual motor for the hybrid system to start the vehicle back up. It doesn't have a starter like most cars. So it just spins the electric motor, which then cranks over the engine, turns the engine back on. But now, instead of doing so, we can actually come to a stop and the engine can shut off completely. And it says that it can propel the vehicle using electric motor alone. A lot of the Prius, if you're doing a slow takeoff, you don't really need to have a lot of power on a slow takeoff. So it won't even turn on the actual internal combustion engine. It'll just power the electric motors until you get to a certain speed, or if you slam on the throttle, obviously the engine's going to turn on. But as far as just a slow, easy takeoff, it's just going to use the electric motors at that time, which then saves gasoline, which then reduces emissions. Owning a hybrid electric vehicle, the fuel economy is higher compared to a similar type vehicle. A hybrid electric vehicle costs and weighs more than a conventional vehicle. The reason why they cost and weigh more is, that's right, you guessed it, the batteries. The batteries themselves can range anywhere from say $7,000 to $15,000 in most economy cars, but I'm pretty much sure that the Tesla batteries are going to be a heck of a lot more than that, but that's and you got to think about the Teslas themselves as electric vehicles. That's the only way you can propel the vehicle. You can't use the internal combustion motor because there is none. So in order to fix the vehicle, if the batteries are bad, you have to replace the batteries, or it just becomes a giant lawn ornament or even a boat anchor. And fuel economy. Fuel economy is obviously going to increase because we're using less gasoline to propel the vehicle. Now we're using an electric motor instead of just a gasoline engine. And when you think about combining the amount of power for both of those forms of propelling it, they don't need to put a giant engine into that vehicle. So obviously now you have a smaller engine, which is going to be sipping fuel rather than chugging it, say like a V8 or a V10, V12. But it's also going to be helping out with the fact that because it's smaller, it's going to use less pollution or create less pollution, and it's also going to need a little bit of help to actually propel the vehicle. So now we have the electric motor that comes into play. So instead of having a 350 horsepower motor inside a small car like that, you have two forms of propelling the vehicle in a combined amount of power. So I would say it's probably around maybe 200 to 250 horsepower these cars have at top speed, top acceleration, top output for the electric motors. But average, you only need about 100 horsepower to actually drive a vehicle around. Most cars in the 50s, 60s, heck, even the 70s. The 70s V8s were only pumping about 230 horsepower. And you got to think about these land yachts that were 6,000 pounds. So now we have something that's 3,000 pounds, and it has probably the same amount of power as a V8 that was back in the 70s. So you can see a lot of these things are coming into play where you have a small 4-cylinder engine and an electric motor. Put them together, you actually have a car that's very economical, and it's actually a decent amount of power. Now, I'm not saying the Prius had a lot of power, but definitely the Ford C-Max. That car is actually really peppy for being a hybrid vehicle. And you're going to see, like, as we start talking about it more and more, you're going to see the different, not to say amenities, but the different advancements we've made with hybrid systems, where now almost every vehicle coming out on the road is a hybrid. They even make hybrid SUVs. So let's go ahead and continue. I don't want to get too far ahead of ourselves. So a series hybrid. Classifications of hybrid electric vehicles. Series hybrid. In a series hybrid design, sole propulsion is by the battery-powered electric motor. The electric energy from the batteries comes from another onboard energy source, such as an internal combustion engine. The engine is only needed to operate to keep the batteries charged. So think of it as an electric vehicle. Think of it as an electric vehicle that has an onboard generator. The onboard generator is the internal combustion engine, which then turns the generator, which then charges the batteries. So there's no force being applied to the wheels by the internal combustion motor, only by the engine, only by the electric motors. So you have the hybrid vehicle battery, you have an inverter. So the internal combustion engine turns the generator, which then sends power to the high voltage battery, or the hybrid battery, sorry. And then as you're applying current through, it's going to power the electric motor, which then goes to a reduction gear, which then goes to the drive wheels. So the engine is there only to charge the batteries. This diagram shows components including a typical series hybrid design. The solid line arrow indicates the transmission of torque to the drive wheels. The dotted line arrows indicate the flow of electric current. So I don't know if you guys can see it all too well. So you have electronic current, so you got internal combustion engine, power the generator, right? The electric current goes in, and then comes out, goes through the motor, controller to the motor, which then goes to a mechanical transmission, which then goes to the drive wheels. Parallel hybrid. The vehicle using a parallel hybrid design can be powered by the internal combustion engine alone, by the electric motor alone, full hybrids only, or by a combination of engine and electric motor propulsion. One of the advantages of using a parallel hybrid design is that by using an electric motor or motors to assist the internal combustion engine, the engine itself can be smaller than would normally be needed. So this is pretty much like say like a Toyota Prius. Very small engine, decent sized motor. You put them together, they provide the same amount of power as not to say a much larger engine, but definitely a larger engine. So you can use less energy from each one, put them together, and it actually propels the vehicle a lot smoother and a lot more economically. So power flow of a typical parallel hybrid vehicle. So now we actually have a transmission that connects the motor and the internal combustion engine to the transmission, and actually will send power either way. So it's either the engine sending power, the motor sending power, or both of them, and vice versa. And then also at the same time, we can actually, I would say, most hybrid systems now we have what is called a regenerative braking, where it actually converts the motor into a generator, which then when you start to slow down, the motor is not propelling the car anymore. Now what it's doing is it switches polarity inside, which then sends power back into the battery. So we're actually charging it while we're driving it. And it's actually pretty cool how they do it. And we also have plug-in hybrids as well. Diagram showing the components involved in a typical parallel hybrid vehicle. The solid line arrows indicate the transmission of torque to the drive wheels, and the dotted line arrows indicate the flow of electric current. So just like I was telling you guys earlier, you have power being distributed from the motor and from the engine together through the final drive assembly to the wheels, but then you also have regenerative braking coming back and is actually charging up the hybrid battery itself. I keep wanting to say battery, not battery. Classifications of hybrid electric vehicles. Series parallel design. Series parallel hybrids combine the functions of both a series and a parallel design. The vehicle operates using electric motor power alone or the assist of an internal combustion engine. So now instead of the electric motor assisting the internal combustion engine, the internal combustion is actually assisting the electric motor itself. The internal combustion engine may be operating even though the vehicle is stopped if the battery is needed to be charged. So now, instead of providing power to the actual through the transmission, what it can do is now the engine will be on and it's charging the batteries while the electric motors are actually propelling the vehicle as well. So not only can it can provide, you have your electric motor, you have or let me show you the picture, it makes it easier. So I know they're going to show it, yeah. So now we have our internal combustion engine, we have our motor. We're sending power through the motor to propel the vehicle itself, but the internal combustion engine can be on at the same time. Still not sending power through to the wheels, but it's actually working its way up through the generator, which then will charge the battery. So that's the one addition that we actually have with this system, is we actually have a generator separate on top of the regenerative braking setup. So now this can actually power the generator, and it can also send power to help assist and send power to the wheels. So what are the three classifications of a hybrid powertrain? So go ahead and give me the first one. Correct, a series. What's the next one? That's correct, a series parallel and a parallel design, yes. So series, parallel, series, parallel. And when we start getting into more Mod 120, we start getting into electrical, you guys will actually see we use this same concept or this same terminology where we're actually talking about different types of electric circuits. Belt alternator starter systems. Parts and operation. The BAS concept is to replace the belt-driven alternator with an electric motor that serves as a generator and a motor. When the engine is running, the BAS system acts as a generator. It charges a separate 36-volt battery or 42-volt charging voltage. The engine stops at idle. The BAS motor is used to crank the engine by taking electric power from the 36-volt battery pack and applies its torque via the accessory belt, and it cranks the engine instead of using a starter motor. So instead of having a starter motor, we actually have a generator slash motor on it. And it's actually a higher voltage than most normal volts that we have in a vehicle. It's not as much as a hybrid hybrid voltage, but it's definitely a lot more than just the accessory battery we have in most vehicles, which is right around 12 volts. Charging voltage is about 14. So for the system, we have a 36-volt battery, but while it's charging, it's pumping at least up to 42 volts into that battery. Now, when we come to a stop, the vehicle turns off. Now, when we want to take off again, what it will do is that generator that was spinning to charge the battery now turns into a motor. That motor has a belt attached to the engine. As it turns into a motor, it actually cranks the engine over. So you don't have a giant, heavy, loud starter starting the vehicle on and off all the time. It is actually a motor-driven belt that actually cranks over the engine as you're about to take off. So this chart shows what is occurring during various driving conditions as in a BS type hybrid. So I'm not going to get too much into this. We're actually going to go over this a lot more in the next 2 lectures. But what they're basically showing is when you actually have current flowing through, it's actually showing that you have an increase, so you have a power assist, right? So you actually have an increase in voltage and amperage going through the system. And then when you step on the brakes, we actually create a charge. And then, let's see, advanced hybrid battery. So yeah, so we lose voltage here, right? That's because we start the vehicle, and now we're actually creating voltage. We have that spike when we step on the brakes, and as it starts to slowly coast back down, it's because what happens when the vehicle starts to stop? Obviously, the voltage and amperage being generated is actually going to start to decrease. So once we come to a stop, it'll shut off the vehicle, and then when you let go of the brake and you step on the gas, it does it all over again. The components of a typical belt alternator starter system. So you have the hybrid battery pack, you have the control module for the actual hybrid system, then you have the converter, which this actually converts AC voltage and DC voltage and vice versa. So if they have DC voltage and you need it to be AC, voltage comes in here, converts it to AC, AC voltage going in, can convert it back to DC to actually charge the batteries. And when we go over more in the next 2 lectures, we're going to see why we want to convert from DC to AC, AC to DC. The dual tensioner assembly, so we actually have the belt, and then the motor generator with 3-phase cable. So this is actually the motor slash generator, and it's actually attached via a belt. And as you start the vehicle, or as the motor converts from a generator to an electric motor, it will crank the engine over, and then as you're driving, it'll convert it back to a alternator or a generator, which then will send it back through to charge up the batteries. This sticker on a hybrid vehicle allows the driver to use the high occupancy vehicle lane or the carpool lane, even if there is only one person in the vehicle, as a way to increase demand for hybrid vehicles in California. And you'd be surprised about how many people bought this car just because they can go in the carpool lane. It wasn't because, oh, I want to be cleaner, I want to drive, less pollution and everything. No, it was actually because they got to drive in the carpool lane by themselves. Now, how many people do you think actually utilize this? I would say a good amount, but not as many as most people think. And no, you can't take one of these and slap it on your car, because most people already know. And then if you get caught with one of these and get caught in the carpool lane, and they find out that the sticker doesn't match with your vehicle, you're going to be in a lot of trouble. The combination starter alternator is used to provide idle stop function to conventional vehicles. This very limited low-cost system is called micro hybrid drive. So I don't know if you've noticed, a lot more vehicles have actually had a there's been an increase in the amount of cars that actually can come up to a stop, the car shuts off, and then when they take off again, it starts the vehicle back up. They're actually starting to utilize this portion of the hybrid system a lot more in most vehicles, just so they waste less gas. You know, if you're sitting at a stoplight for 5 minutes because it's a slow day, that light, or the, I'm sorry, not that light, but that time you're sitting there and idling, that's just fuel being used up. Now it will say shorten the life of, or the system obviously will tend to get old, and you do have to replace it, but at the same time, you're saving a lot more on actually how much gas you're wasting, and you'd be surprised at how much gas you actually waste just sitting at stoplights. So what is the main advantage of a BAS system? Low-cost hybrid features. So this system here, like I said, there's not much to this the BAS system, but it helps lower down emissions, and then also increases fuel economy because you're obviously using less fuel. Modes of operation. The following are the most common features of hybrids that improve fuel economy. Idle stop. The idle stop mode turns off engine when the vehicle is stopped. Regenerative braking. When decelerating, the braking system captures the energy from the vehicle's inertia and charges the battery. Power assist. The electric motor assists the internal combustion engine during acceleration. Engine off drive vehicle mode. The electric motor propels the vehicle at lower speed. So let's say you start running out of, you're really close to empty on the vehicle, you don't want to use up the rest of the fuel. You can actually put it in just electric mode and actually use the electric system, just the batteries and the electric motor to propel the vehicle. So it can save you that little bit of gas, or if you're completely empty, you can still utilize this system to actually get you to a gas station or wherever you need to go. And then if the batteries are dead on the vehicle itself, regenerative braking will actually help charge up the battery while you're actually driving. And then obviously, like the Prius, they actually have the newer ones, like the Prius, the plug-in hybrids, is a hybrid system, but you can actually charge the battery while you're at home or at a charging station. And it's only like, I think it's like $3 or $4 to charge it up, but obviously you have to let the car sit there for a good while. Mild hybrid, levels of hybrid vehicles. A mild hybrid incorporates idle stop and regenerative braking, but is not capable of using the electric motor to propel the vehicle on its own. So it can help the vehicle propel, but it's not solely used for propelling the vehicle. Medium hybrid. A medium hybrid uses 144 to 158 volt batteries that provide for engine start-stop or stop-start, regenerative braking, and power assist. And a full hybrid, also called a strong hybrid, uses idle stop regenerative braking and is able to propel the vehicle using the electric motors alone. So as you can see, the more aggressive you get with the components of a hybrid system, the more you're going to be able to benefit later on in the long run with having a full hybrid as opposed to having a mild hybrid system. What are the three levels of hybrid vehicles? Mild, medium, and full hybrids. That one's pretty easy, we just talked about it. So this is a very quick lecture, it's just an introduction to hybrid systems, but I definitely want you guys to get the hang of what we're going to be going over. Really dive into the chapters, and go beyond just what I've been telling you guys in the lectures, in these next few lectures, because there's a lot of information. I can try and cover as much as I can, and like I said in the last ones, you guys have any questions, please feel free to message me. Email, text, call. Don't call me at 3 in the morning though. Probably won't answer. But if you do have any questions, you guys let me know, and that's what I'm here for. So, but other than that, that's pretty much it for this lecture. It was pretty quick, but we're definitely going to dig a lot deeper in these next 2 lectures throughout this week, all right? So I'll talk to you guys later. Bye.